Professor Baldwin here, and today we're going to go over some of the properties of logarithmic functions. Our first property is the product rule, and that says a log with a given base with two values multiplied together can be separated into two separate logs with that same base. Notice the base stays a for all of them, and you can separate them with addition. Our first example, we're going to see how to express this as a sum of logarithms and then simplify if possible. So we're going to end up with log t of 8 plus log base t of y. Our second rule is the power rule. And that's if you have log base a of m to the power of p, that exponent or the power can come out in the front of the log. So looking at this example, we have the natural log of the cube root of 4. Well, we need to remember that the cube root can be written as an exponent of 1/3. So this is the same as the natural log of 4 to the power of 1/3. And using the power rule, you can take that power, 1/3, and put it in front of the natural log of 4. The next rule we have is the quotient rule. And the quotient rule tells you that if you have the log of something that's being divided, you can separate the numerator and the denominator into separate logs. So in this example, we have m divided by 8. So the numerator becomes its own log. So log, we keep that same base of t and we put the numerator minus log. Remember, we have to keep the same base of t, and then we have the denominator. Now, the last example for this page, we have to express this log in terms of sums and differences of multiple logarithms. And notice that there's a lot going on. So let's just go piece by piece. Let's start in the numerator and start with p squared. Well, the p squared, we can use the power rule, which says to bring out the 2, keep the log base b of p. Then if we move on to q to the power of 5, well, that is being multiplied by the p squared. So we can use the product rule, which means we're going to add these logs together. Use the power rule, which brings the exponent of 5 out, and we have log base b still of q. Now we can move to the denominator, which means we're going to do subtraction. Now looking at m to the power of 4, we use the power rule, which brings the 4 out in front of the log. Keep the base of b, and that's of log of m. M to the power of 4 is multiplied to b to the power of 9. So we can add those together using the product rule. Also using the power rule to pull the 9 out from the exponent, we have 9 log, same base of b, of b. Now you'd think that we're finished, but you need to remember what happens when you take the log of something with the same base. So the base is b and we're taking the log of b. Remember that this thing simplifies to 1, which means our whole expression simplifies to 2 log base b of p plus 5 log base b of q minus 4 log base b of m plus 9. Okay, what if we're given one that's already expanded and we need to combine it into a single logarithm? Well, again, go piece by piece. This first part tells us the 1/2 is the exponent for the x. So it's x to the power of 1/2. The next part, the log stays the same, log of base a. There's a 4 in the front, which means it's the exponent for the y. They're separated with addition, so that means these two get multiplied together. So y to the 4th. Next, we have subtraction, which means division, or the quotient rule. We have an exponent of 3, log a of x. So this is x to the power of 3. And they all had the exact same log of base a. So this is log of base a. Now, is it simplified? No. And it's not simplified because we have an x in the numerator and in the denominator. We want to only have one x and one y value. So we need to use our exponent properties. So remember, we'll keep the y to the 4th. Remember that an exponent that's negative moves it from either the numerator to the denominator or the denominator to the numerator. So we can take x to the 1/2 and make it x to the negative 1/2 by putting it in the denominator. That allows us to combine it with the x cubed. But in order to combine exponents with the same base, we need to add their exponents. And to add their exponents, they need to have a common denominator. So we'll keep our numerator of y to the 4th. And we're looking for a common denominator between the negative 1/2 and the 3. The common denominator will be 2, and 3 could be written as 6/2. Now, remember that we add those exponents together. Oh, I didn't give myself enough room for my log. Log of base a. So y to the 4th stays in the numerator. We are combining the exponents for our denominator. So negative 1/2 plus 6/2, which is x to the 5/2. Now it's simplified because we only have one x and one y. This next example, we're given some approximations for different logs, and we need to use the rules that we've learned in order to evaluate these two examples. So we're told that log base a of 2 is approximately 0.301. Log base a of 7 is approximately 0.845. And log base a of 11 is approximately 1.041. And we're asked to find each of the following, if possible. And then we need to round the answer to the nearest thousandth. So, log a of 2 over 11. Well, we can use the quotient rule to separate this out as log base a of 2 minus log base a of 11. And we know that log base a of 2 is approximately 0.301. Log base a of 11 is 1.041. Do the subtraction and we get a result of negative 0.74. What about log a of 98? Well, we need some combination of 2, 7, and 11. Well, I notice that 98 is even. So if I factor out a 2, I'm left with 49. Well, 49 is a perfect square of 7. So we can rewrite this log base a of 2 times 7 squared. Now we can first use the product rule to separate this out as log base a of 2 plus log base a of 7 squared. this first log base a of 2 stays the same. The second term, we're going to use our power rule to bring the exponent of 2 out front. 2 log base a of 7. Now we know the value of log base a of 2 and log base a of 7. We substitute those in. 0.301 plus 2 times 0.845. Punch that all into your calculator and you get 1.991. Two last rules. Log of a base to a power, which says if you have a base a and a log of base a, the answer is just the exponent. Those bases cancel each other out, the base of the log and the base of the exponent. That's this first example. So notice that the base of our log is e and the base of our exponent is e. That means the answer to this is just the exponent, the absolute value of x minus 4. Our next example is base to a logarithmic power. So if you have base a and then you have the log with base a of some value, the result is just that value. So the exponent of a and the log of a simplify each other out. So here, notice we have a base of 3 and our log has a base of 3. So the result is just the exponent of 4x. So this is that example. Lots of properties of logarithmic functions. They take a lot of practice, but if you still have a question or you get stuck on a problem, leave it in the comments and I'll be happy to make a video for you.